Hello people, Kweku Ifa here again. This is episode 3 of the Introduction to Microcontroller Electronics, Hardware Programming and Robotics series. And in the previous episode, which is episode 2, I introduced us to the official software for programming all forms of Arduino boards, right? And I also did some kind of unboxing where we looked at some of the major components in the Arduino Starter Kit. Good. So this particular episode is going to be more of action, or this is where all the action begins, because in this video, some of us for the first time are going to have our first experience with building of electronic circuit. Some of us are also going to have our first experience with programming of hardware electronics or anything of that sort. So I'm happy that you are still following this series up to now. I'll urge you that from this episode onwards, you will always try and make sure that you have your Arduino Starter Kit by your side each and every time you attend to these videos, so that you can be practicing along, because there wouldn't be any fun in it if you are just watching and gain all that knowledge without the ability to replicate some of the things being done in this video in the comfort of your houses or your offices. Yeah, so without much to say right now, let's just jump straight into it behind me and then let's get it started. Okay, so when we were doing the unboxing in the previous episode, I mentioned the breadboard, and I made mention of the fact that it's a very important component when it comes to prototyping, and you'll be using it like very often, very often, because you'll be building temporal circuits on it, and then you can dismantle the circuit after build new circuits and all that. Yeah, so I want to quickly show you how the breadboard works, and then we will build a very simple circuit with it. So to assist with this lesson, I have I'm going to be using this particular online simulation tool as well, which allows you to make electronics connections or to build electronic circuits online or virtually as well. So before that, I took a very old breadboard, and I'll quickly show you what it is actually made up of. Okay, so I took this old breadboard from a very old kit I had, and it's amazing. You can see that there are many holes on the breadboard, and then these holes are for the connections. Actually, let me take some few jumper wires and show you something. So, ouch, this is very hard sometimes. Okay, so I'm just taking a strand of a jumper wire, and the pins of the jumper wires, they go into the breadboard. So all the connections we are going to be making, we're going to be inserting them into these holes in the breadboard. But from basic electronics or basic concepts of electricity, we know that plastics do not conduct electricity. Plastics do not conduct electricity, so there must be actually something that is helping breadboards to conduct electricity in the circuit, or to help in building of electronic circuit. When you flip your breadboard behind, there's usually a covering, but I have removed all that covering from there just to show you what is actually behind the breadboard. So you can see that some of the there are some strips of metals. Some are running horizontally all the way from the left to the right. Most breadboards, some of the strips usually run from the left, and then it terminates somewhere in the middle here, and then another one continues from there all the way to the right. The same thing with the down. One from the left all the way to the middle, another one continues from where it stopped, and then it also continues all the way to the right. Yeah, so there is a break here. Yeah, and then the rest of the, how do we call it, the rest of the metals in the middle section of the breadboard are also running vertically. Short strips of metals that are running vertically. This way, whenever you turn the breadboard this way, you should always have in mind that yes, there are cables or metallic strips running all the way from the left here. It goes all the way to somewhere in the middle here, and another wire continues from here all the way here. The idea is that if you should connect any form of electricity or any form of signal to, let's say, this particular pin, that signal you have inserted here is now available all through this area. I'll show that to us in the simulation shortly. Anything you connect to any part of when I connect anything here, for example, it means that whatever is available in this blue cable is also available on all the pins that share the same strip. I hope you get it that way. Good. If I should move it from here and insert it somewhere here, it's the same. Since there's a break here, as I mentioned, it means that whatever is in this signal, or whatever this signal is carrying, whatever this wire is carrying, is available all throughout any single pin, any single hole here that shares in the same, how do we call it, bus or metal strip. Any hole that leads into the same metal strip are going to be sharing the same kind of signal. Yeah, the same applies to the row at the top as well. However, with the ones in the middle section here, since we know that those strips are running vertically, it means that if I should connect anything to this particular hole, it means that that signal is only present in let me say a very short part. Only 1, 2, 3, 4. Only these 4 other holes share the same signal with it. We'll look at it on the screen also shortly. If I move this cable to another place, the same thing. So if I should take this cable, connect it to another place here. Now what I've actually done is the metal strip below where I have inserted this part of the how do we call it, the cable, now share the same signal or the same bus as the holes here as well, because I have connected this way. So here shares with here. Yeah, if I should change the position, it means here shares with here. Yeah, so those are the type of connections you are going to be doing with cables and then how do we call it, and breadboards from now onwards as we continue. Let's jump into the simulation and let me show us what I just talked about right now. Okay, so as I was saying, this is the, how do you call it, the virtual form of what I just showed you. So right here we have the breadboard, and then this is also the Arduino Uno. Let me put this aside for now so that we can just concentrate on the breadboard. So just as I said, the pins in the middle area of the breadboard, they run vertically. So anything you should connect here, you can see what is the number of holes that are highlighted. It means that they share the same kind of bus system. And then the ones that are running horizontally too, if I should click on this, you can see that they share the same kind of how do you call it, they share the same signal as well. Whatever I connect here runs all the way across. Yeah, because I think because this one is a virtual simulation, I don't really see the break in the physical world. Some of the breadboards, like the one I just showed you, has a break in the middle, so the connection does not continue smoothly. Yeah, just pay attention to that. But for this virtual one, I am sure that whatever you connect here is available all the way through to the end. Yeah, same with the red part. A copy of that is also below here, and then the middle section is your work area. The interesting thing is because there are more of the vertical ones than there are of the the horizontal ones. It is wise enough to limit these horizontal ones for just power. Just take note of that. We're going to usually use the horizontal ones for making connections that's got to do with the main like voltages that you'll be using in your circuit. And mind you, in this particular type of electronics, we are going to be usually playing around with voltages between maybe about 3 volts to 10 volts, but mostly 5 volts, sometimes 12 volts, depending on the type of load you are trying to control and all that. But we are mostly going to be dealing with 5 volts because the Arduino Uno, for example, operates in the 5 volts region. Yeah. Okay. So I want to build the simplest form of a circuit that may not even require any programming. For example, I just want to press a button and then an LED should just come on. It does not require any form of programming. And also I don't want to use any breadboard. Let me just put the breadboard aside and let me pick up an LED from here. By the way, a link to this particular virtual software I'm using will be in the description, so you can check there for reference. I need an LED. An LED is a light emitting diode. I need a resistor. Okay, is there anything like a battery here? Okay, I think there's a battery. I can see a 9 volt battery here, so let me use it. Okay. So I'm building this particular circuit without even using a breadboard. Okay, maybe let me get a switch as well. This is a push button. Let me use it. Okay, let me use this push button. Okay, so what I want to do is that if you've never connected an LED in a circuit before, this is how it works. It has 2 pins, and then one of the legs of the LED is positive and one of them is negative. The technical names are anode and cathode. So this one here, oh, this software is really good. If you just hover on it, it actually shows you the names of the the pins even. Yeah, so the anode is where usually your positive signal goes to, and then the cathode is one that goes back to ground or negative. So since I have the positive part of my battery here, let me connect my how do you make connections with the software? Okay, all right. Okay, so I've connected the positive part of the battery to the positive part of the LED. Do you know what? I could have just connected the negative part of this particular LED also to the negative part of the battery. However, this is going to be a catastrophe for the LED because this battery is rated at 9 volts, and usually these LEDs usually accept a maximum of about 3 volts, so it wouldn't be wise to just connect them straight ahead. So one thing that you can do is to introduce a resistor somewhere. So I want to break this connection. Let me delete it, and then instead of connecting the wire directly, I would rather connect I'd rather connect the negative part to a resistor before connecting that resistor to the cathode of the LED. This way, if I should run the simulation right now, I guess the LED should just light up. Let me see what will happen. Okay, so apparently this power source is not suitable for simulation, right? Okay, let me just then maybe instead of using the 9-volt battery. Let me just use some power from the Arduino board itself. Good. So here is the Arduino board, which you can find in your kit as well. And before I even talk about all the pins on the Arduino board, I can show you. You can see 5 volts here, and you can see JND. JND means ground. So you have 5 volts and then you have ground. So instead of powering this whole circuit with how do you call it, with 9-volt battery, we're just going to power it with the 5 volt that we can get from the Arduino. So I'm going to take power from the Arduino and rather connect it to the positive part of the LED, and also connect the negative to the negative part of it through through the resistor, then to ground. I'm sure this one will let me be able to run the simulation. Let's check. Okay, so as you can see, the moment I run the simulation, the LED itself is on. It's on. This one, it doesn't require any program. You don't have to write any kind of codes for the LED to come, because it's a straight logic. Let's do something better. Let me stop this. Instead of also connecting directly, let me put a switch somewhere in the middle. So the ground should go to one part of the switch, and then the other part of the switch should also go to the resistor. Okay. Okay. All right. The circuit looks funny, but we take it like that. So, if I should run this simulation as well, you realize that it's running now, but this time around the LED does not come on automatically. It will only come on if someone pushes the button, and this is not a type of button that holds itself. So you have to press and hold for the LED to stay on. The moment you release it, the light also goes off. So that is how it works. So you see, this type of circuit does not require any form of programming at all. These are just all, let me say, an analog procedure, analog way of building electronic circuit. Good. Let's try and implement the same thing this time around on a breadboard. So here is the breadboard, and let me delete all the connections that we made just now. Good. So I made mention of the fact that this part of the breadboard, these very horizontal ones, usually it is best if you use them for power. Okay, so I'm going to take 5 volts from the Arduino board, and then I would like to connect it to this part that is highlighted red. Good. Let me keep it this way, or let me raise this up a bit. Good. And then also I'm going to take another wire from the ground, and then I'll connect it to the lower part. Good. So now it means that 5 volts from the Arduino is present all throughout this red part. Mind you, in the physical world, as I said, there's usually a break somewhere here. So the 5 volts wouldn't have gotten across all the way to the other end. It will stop somewhere in the middle. If by any chance you yourself you need the power to cross, then you have to use, let's say, another wire to actually do the like some sort of jumping connection, so that when the power comes to reach here, then it continues and flows to the other side, that kind of thing. Good. The same applies to the negative part. In the real world, you may need to do something like this in order for the power to cross on some breadboards. In the robot you may need to do something like this before everything works nicely for you. Good. But for now, as you can see on the screen right now, the how do we call it, the 5 volt power is present all throughout here, and then the ground connection is also present all throughout here. So let me bring the LED into the breadboard, or onto the breadboard. Yep. This is the way to connect a typical component like this that has 2 legs on a breadboard. You don't connect them this way. Is there any way I can flip this thing around? Okay, I don't see anything like that. I wish I could just rotate it by 90 degrees or something. Yeah, I'll show you that on the breadboard. But this is how you connect. You connect it in such a way that the each leg of the LED is sitting on its own or a unique bus. So you can see that the cathode is sitting on this particular bus highlighted in green, and then you can also see that the anode is also sitting on this particular, how do we call it, bars also highlighted in green. These 2 bars, they do not communicate with each other, or they do not have any, they are isolated. They are electrically isolated or electronically isolated from each other. Good. So I can now take, since there's 5 volts present all the way here, I can now take 5 volts from anywhere here and then plug it here, right? And then since ground is also present here, I can also take ground here and then connect it here. But mind you, as I said earlier on, if you should do a connection like this, it means that you are introducing this particular LED to the entire 5 volt power that is coming from the Arduino board, which is very bad because the manufacturers usually build these LEDs to hold voltages of about just 3 volts. So if you're introducing 5 volt to it, that's over voltage. So you may end up frying the, if I say frying, I mean burning. You may end up burning the LED. Yeah. So it is not wise to do this. So let me delete this one and then bring a resistor. I think I deleted a resistor. Let me bring a resistor back here. Okay, so the resistor also has 2 pins. So in the same way, the best way to put a resistor in your circuit is to make sure that each leg of the resistor is also touching separate legs. So you can see that this leg is touching here, and then this other leg is also touching here. So they are sitting on 2 different cables or bars. Yeah, and they are independent of each other. So you can now connect this resistor through a very short jumper wire to the cathode of the LED, and then from the resistor you can now come all the way down to ground. Ground means negative. If this particular circuit is put, ground can mean something else in another circuit, but in this particular circuit, ground means negative. Good, because your power is positive and negative, 5 volts and ground. It is worth noting that electricity flows from the positive side to the negative side in such a circuit. So the current will be flowing from here. When it reaches here, it continues. It is available in the entire bars here, and then this cable taps that same voltage 5 volt and gives it to the anode of the LED. The same thing. This particular cable now takes whatever is available at the cathode and then drains that current through a resistor to the ground, and that completes the circuit, right? that complete the circuit. So if I should run this, the LED will come on automatically. It comes automatically. It doesn't need our intervention because the switch hasn't been used at all. If we want the switch to be used, we have to do something. We have to maybe break one connection, introduce some sort of switch, which I'll put mine here, and then you can also now continue from the other side of the switch to the ground this way. Okay, so if I should run this particular one now, it's running. As you can see, the LED here says on, but the LED here is not on because there is now a switch here. Until I press it, you don't see the LED on, but if I do, now the LED comes on. If I should release it, the LED goes back off. So this is how to also build circuit on a breadboard. Yeah, so I'm going to try and build the same circuit physically. Yeah, you will find this particular sachet in your Arduino starter kit, and in it you will find something like this switch over here. So I've inserted a switch into the board this way. Once you are done, you will need to use this cable. This one goes into the Arduino board, and then the other side of it goes into your computer. This one goes into your computer. Okay. Okay, so as you can see, the Arduino board itself is out. Right now the Arduino board is powered up, and then because of these two cables, there's also power present on the breadboard, 5 volts along the red line, and then also ground along the blue line here. So if I should now press my button, I should expect my LED to light up. But if you notice something, because I don't have a resistor in this circuit right now, the LED went on full brightness, and then it quickly dimmed again because it looks like the incoming power overwhelmed the LED or something. So let me get a resistor and then put it somewhere there. Okay, so now if I should turn it on, let me replace this LED with a new red LED. Let me see if the brightness remains the same. Okay, so that's a new LED right there. Okay, I don't think there's much difference. Okay, so hopefully nothing is wrong with the first LED. Or am I wrong? Okay, absolutely nothing wrong with it. Yeah, but just know that it is not a good practice to build such circuits without using resistors in your circuit, because in some scenarios you could end up frying whatever load you have inserted over there. Yeah, So yeah, try and build, if it's your first time, try and build a similar circuit, and maybe take a picture or a video of it and then share it on your social media. And then you can also tag myself and Aaenics, and let's see what you're also doing out there. Yeah. Okay, so it looks like we have used the entirety of episode 3 to learn about the breadboard and how to build our first electronic circuit, which I think is worth it because we've learned things that we are going to be using in subsequent projects that we will be doing. In the next video, we will quickly do a second type of circuit. This time, instead of using the push button, we will use something called a potentiometer or a variable resistor. This time around, we are not going to control the LED coming on or off. We are going to actually control the brightness of the LED. Instead of just telling the LED to either come on or go off using the push button, we are going to be using something called a variable resistor to control the brightness of the LED. Then from there, we know that we have been able to cover something digital and something analog. I'll explain that in the next video. So jump into episode 4 and then let's continue from there. Thank you.